Okay. Thanks everybody for sticking around to the end of the day. This session is on an introduction to singularity containers for scientific and high performance computing. We only have 30 minutes for today's session, so I don't have a lot of time to cover a lot of detail. I know Mahidar covered probably more than I'm going to be able to cover today about the different types of options and things that you have with singularity containers in terms of bringing your code to an HPC system. So I wanted to kind of do this a little differently than other sessions. I have an idea of what I want to do maybe in 30 minutes to get you started with singularity containers on Expanse, but the first thing we're going to do if you go to the repository is do a quick poll. So Cindy should hopefully have a Zoom poll lined up for us. And it's got about, what, 6 or 7 questions that I kind of want you to answer to give me a better idea of like sort of what your familiarity with containers is right now, and if you've used them before, and just get a sense of where people are with containers. If you've been in sort of the data science, machine learning track for the last 2 days, you've been using containers. So, don't count that as prior experience. I'm really curious about like, if you kind of have an idea of what a container is, have you previously used containers prior to this week? Maybe you're more experienced and you've already used containers as part of your work. Maybe you've even developed your own. One important topic for Singularity in particular is sort of what operating system do you sort of have access to regularly, because it really only runs on Linux, and most people aren't, in my experience, running their own Linux boxes. Yeah, so that's the quiz questions there. We'll give it a minute here for the answers to come in. Please try to answer as best as possible. I didn't really do probably any sort of real scientific, design to the poll, just kind of questions that I'm curious about, for sort of today's session, but also sort of future development for the type of material that we'll put into this talk in the future. So while we wait for the poll to come in, I might just go with my plan as it is, because so far the yeses are outweighing the no's in, a few of the categories. At least like the first two, like the talk that I usually give in this section really covers the first 2 questions for the most part. Kind of, you maybe know what a container is, maybe not, and so I sort of go over the basics and try to get all the way up to starting to work with Singularity. So we sort of split on yes and no on that question. So I'll briefly answer that topic, and then walk you through like at least hopefully an easy exercise or two to get you sort of playing with Singularity, which is a container runtime, essentially for HPC systems. Anyway, okay, so the poll is almost up. Cindy, when it's done, can you just save the answers for me?
Absolutely.
Okay.
And then you might have to close it off on your screen so it doesn't appear during your presentation.
Okay. All right, I'll close it now.
Yep.
Okay. So thanks for taking the poll. It'll definitely help me sort of maybe focus some of the stuff in the future. But what I do want to point out is we do this talk fairly often. I've already done it twice this year, and sort of it's been evolving for a couple of years now. So there are longer versions of sort of an intro to Singularity that are available now or will be available in the future. For example, if you click on these other references down here, there's actually one I gave back in March that's sort of almost like the one that the slides that you'll see are available in a repository here, so you can watch an hour-long talk that I gave a couple months ago here on some of those basics of answering what a container is and kind of walking all the way up to using Singularity. There's also one I gave about a month ago at a different workshop. The video is not posted yet, but the slides are available here. It's called the Essential Singularity, which is kind of answers that question: what is a container? What is singularity, and sort of the three essential commands that you really want to get familiar with when you start working with Singularity. So for those who aren't familiar with containers, I do want to answer that basic question before I sort of push off into more advanced things, but I think there'll be a good reason for that. So a software container is really an abstraction of a set of technologies that it's available sort of on Linux systems. You can run containers on Macs and Windows systems as well. But for Singularity containers, they run on Linux, and they use all of these different bits of Linux tech that's on pretty much any Linux distribution that might be using. And the idea of a container, though, is really to create, to solve the problem of how do you get software to run reliably when you move it from one computing environment to another. So when you want to take your software, say, from the campus cluster that you're running on at your university, and you want to bring it over to Expanse or some other HPC system that you now have an allocation on, and you want to do more sort of work over on that allocated resource that you have. So that's really what a software container is. It's really this sort of software bubble that you're trying to create. If you're familiar with working on the Conda environments, it's kind of like creating your own isolated Conda environment, but wrapped in a file, and you can move it around and take it with you to different HPC centers. To your campus cluster probably has Singularity. It's pretty widely available. And Singularity is simply a container runtime, a container engine that allows you to run these containers on a system. So Singular was basically developed because you can't run, if you have heard of containers, you might have heard of Docker. You can't really run Docker. It's not really designed to run on HPC systems. And that's why Singularity is born. And so that's what we all use on HPC systems. And so if you're going to get into containerization, you can definitely learn Docker, because one thing that Singularity can do is convert Docker containers into Singularity containers. But if you're going to run a container on an HPC system, you have to run it usually as a Singularity container. There are other container engines out there in the HPC space, but I think Singularity is still the most widely distributed. So yeah, I would definitely recommend, coming back to this reference if you're, just not quite familiar with Singularity or containers in general. I go through sort of the basic definitions, and for the people who had seen the movie The Matrix, I do have this kind of analogy: is like your container is to the supercomputer like the construct is to the Matrix. So if you haven't seen the movie, basically there's the characters in the movie, they go into this computer simulated world, but they have their own program outside of that simulated world called the construct. And so they use this program that they have themselves outside of the matrix to load anything that they need. So the clothes, the wear, the weapons they bring in to fight the bad guys. You can kind of think about the container engine like Singularity or Docker as your loading program. You can load anything you want into these containers and bring them to where you need to do your work. So that's kind of the analogy and why the matrix question was in the poll. Cindy did remind me right before we started today that the new Matrix movie did come out recently, so probably a fair amount of people have seen the movie. I just figured I'd test whether or not I need to update my movie references for today's talk. Okay, so there are, again, slides and already recorded videos available if you really want to listen to me for an hour. We only have 15 minutes left here, basically. Also, for those of you who joined me for the advanced GitHub the other day, Andrea Zonka, who developed that material, is actually developing a tutorial for running Singularity containers on Expanse as well. So I think it's still in the works, but you can definitely check it out. It's another good resource. This Cornell site, they have a bunch of different virtual workshops on different topics. This is just one that he is updating from sort of the original that we made in, I think, 2018 at SDSC. So that's another resource to sort of learn more if you're interested after I show you kind of what we're doing there. So what am I going to do here? Let's see. So I'm going to open up my terminal and log into Expanse to my training account. And I'm going to load my Singularity Pro. I want to go load Singularity Pro. So this is a particular version of Singularity. So Singularity was actually originally developed at Lawrence Berkeley Lab. It was spun out to a commercial entity to try to commercialize the software, which is still ongoing. And so this is why we have a Singularity Pro version. We actually have a paid license for Singularity on Expanse. So you'll see different versions of Singularity. The name of the company is SciLabs. So if you Google SciLabs, you'll get to their website. I'll place this in the Slack here. It's also in the slides for reference. If you want to go to the website, part of the exercise will involve going to the website if you have a GitHub account. So this is the company. So there's user guides over here. So there's a nice user guide for Singularity. So if you want to, read through this, you'll get a lot of the type of information about, what Singularity is, what it can do, all the different options. There's, it's really good documentation. The one thing I will mention before I turn back to the quick set of exercises is, unfortunately, as many open source projects experience, sometimes there was a fork of Singularity created. So all of the code for Singularity is open source. It's on GitHub. The company is still developing the Singularity CE, which is the community edition. We have, again, the Pro edition. And there's like an enterprise version I think you can get. But if you also Google Apptainer, this is the new fork of Singularity from many of the original developers, actually, I would say. I think that's a fair statement. So you might see on your campus cluster or some other HPC system in the future, you might see both Singularity and Apptainer. I imagine that's going to probably happen on Expanse at some point in the future when these two branches of this project get too far away and different features are needed by different people. They're not maintaining any sort of compatibility long-term as far as I'm aware. So just something to be aware of if you are, especially if you're already working in with Singularity a lot. Okay, so back to SciLabs. So I'm going to go to the SciLabs website. Now, we have, as Mahidar mentioned in the code migration talk, and as the people who've been in this sort of the data science machine learning track, we have containers available on Expanse. And CM shared apps, containers, Singularity. So we maintain different packages in Singularity containers ourselves, for example, like TensorFlow. We have each of these files a different version of TensorFlow installed in one of these containers. Obviously, kind of you can see there's different versions that have evolved over time with different maybe CUDA packages and other things. And we build containers and maintain them for users on our systems because some of these packages are really hard to support natively, like compiling them in the operating system we actually run on Expanse. So we actually run Rocky Linux, which is CentOS, sort of the replacement for CentOS on Expanse. But packages like TensorFlow and PyTorch, a lot of their sort of build processes usually run on it's like Ubuntu operating system, which we don't have on Expanse. And there's lots of assumptions made, in that process of compiling that software that actually is sort of kind of tied usually to the operating system that they generally support. So one thing containers are good for is that type of problem. If you only have a package that you can sort of easily build and regularly support in one operating system, you can use sort of the operating system of another distribution inside your container, right? Then is available on the HPC system you're working on. So that's one sort of big reason we use and maintain containers for users on the system for these specific applications that we just can't easily build outside. Now, again, with things like TensorFlow and PyTorch, those are also available in sort of the Anaconda distributions. You can definitely use those. There's just limitations to those that were discussed. I think Mahi discussed with when you have to start doing multi-node things, it gets more complicated to use Conda built binaries for those packages. So that's why we still maintain our own in these Singularity containers. So for example, right, just to do a quick illustration, one of the basic commands in the essential Singularity talk that I gave about a month ago is the shell command, right? So one of the exercises that talk walks through is sort of checking out all the different versions of Python you have access to on Expanse. So this Python here is the default one that comes with the operating system when you log in. Right, so you can check what Python it is there, but you can see one of the powers of Singularity is you can Singularity. You can log into that container. You not only now have a different sort of operating system environment, but you have any sort of version of Python that you might want. Right, so in this case, it's not too far away from what we're actually running in the operating system, but you can start building these software environments and customize to anything that you need inside that container that that we either don't want to install on the system natively for you because it's too hard, or it's just too hard to maintain for us, or it's just your workflows are so specialized. What we would usually do is just have you install it in your home directory. We wouldn't install it like in a central location on the system itself. So one other option, instead of installing it in your home directory on every HPC system you go to, you could build your own custom container, right? To have all the things that you need, and you don't have to bother us. You can use all of the instructions that that you might find online with sudo apt-get install this, sudo apt-get install that, or yum install this. You can do all that inside your container if you're familiar with the Linux package management systems. Okay, so again, we have 8 minutes left. So one of the hard things, which I think I saw in the poll, is most people don't have regular access to a Linux system where you also have root access. And that is one of the problems with getting people sort of started working with Singularity. Because again, the fundamental selling point is I can build my own container, I can put whatever I want in it. and take it to any HPC system and run my work there using the container. And it's all sort of portable, and reproducible. It's a really nice way to do things. However, to build a container, you need root access to a system, and we don't have root access to Expanse, so you can't build your container on Expanse, right? So if you wanted to develop your own custom container, you have to generally what people with, say, running on Mac or Linux do is, or sorry, Mac or Windows, is they install some virtual machine engine and run a virtual machine on their Mac or Windows system, and then install a Linux virtual machine, run it, install Singularity there, and build the containers in that virtual machine, and then send it out to wherever you need to do work. That's definitely an option. I was working with a Mac for the last 2 years, and that's what I was doing sometimes. However, that's not sort of an ideal situation long term, depending on how involved you get with building containers. So there are a few different options out there. One for everyone today to get really, if you want to build your own containers, is Scilabs does have a free small sort of cloud remote build service that you can use for free. So that's kind of what I want to show you, just how easy it is to actually get set up and start building your own containers if you really want to. And so that's what we're going to do in the next 5 minutes if you're still following along. So if you go to the Scilabs website, which was pasted in the chat, you'll see this SCS login. So that's for the Singularity Container Services. And you can follow the sign up process. It should be fairly straightforward, if I recall. I already have an account, so it's not too hard. So you can follow the sign up. What I would recommend, if you're just playing around with it, is to sign in with your GitHub credentials. So I think, we assumed, I think for most of the GitHub sessions, that everyone would sign up for a GitHub account. So you hopefully should have a GitHub account. You can see here that the remote build service, you get, 500 free minutes a month, and there's 11 gigabytes of storage. It's not a huge amount, but it'll cover, pretty basic containers if, you don't need too many, too large of containers to help you build your containers. And this is what it looks like. You should have you might have to create your first project. I just named mine mCanvas. And the key thing to get set up with remote build service on Expanse is you have to create an access token. It's up here in the top right corner. You'll just click on that and then create a new access token. And I'll just do XDTR 108. And you copy that to the clipboard. That's the process. So you will copy the access token that you get, and you'll do Singularity, I think, remote off. No, I think I might have got that backwards. Oh, sorry. Clear. Singularity login off. Let me check the documentation. So if we go back to the documentation, the documentation is build a container. Oh, here's the Scilabs Cloud Library. There we go. So yeah, the documentation for the Cloud Library, I'll put this here in the chat. You can follow. Of course, now I need to go back and copy this. So it'll walk you through the Singularity remote login. That's the command I was looking for. You'll just paste your access token in. Oops. Not. Copy and paste is not working well on my new machine right now. There we go. So it'll store that access token in your account. You can definitely revoke access to the keys later. Just go back there and then revoke token. But so this is the remote build service. You can actually input what we call definition files here in this sort of interactive terminal on the Scilab's website itself. But you know, the cool thing is you can kind of actually build containers on the Scilab's cloud, starting from Expanse or whatever HPC system you set up your remote access to. So one thing that Mahidar mentioned about code migration, especially if you're going to come to Expanses, we actually have online all of the containers definition files that we use ourselves. So put this in the Slack. So you can actually clone this repository to your home directory. And check out all of the different definition files. These are essentially the manifests of all of the packages that we would install in the containers that we have. So for example, if I check out the Singularity Ubuntu 2004, this is the definition file. So there's a different pieces to the definition file. You can learn what the different ones are, about what these different special lines mean, about how we're setting things up. But basically there's these different sections. Like the first one here is labels with metadata, environment variables you can set. The post section is where all the business happens about, you know, defining what's going to be put in your container. So you can see here a lot of apt-get installs of like the common packages we want. Like we'll always put, you know, a Fortran in the Ubuntu containers, because that's sort of this is our base container we build other ones off of. And so yeah, so definitely this is a great resource. And since I'm already 1 minute over time, if we go back to the cloud containers here, you can use the remote builder, right? So if I do a singularity build remote command, I can build. If I modified, say, this Singularity Ubuntu 2004 file, I can just do a new Singularity image. If I have all the access set up, what it's doing is it's basically sending my updated definition file to the remote builder cloud. It's starting the build, and it's going to go ahead and build that container and then send it back to Expanse for me, right? So again, this is like one of the big, like, I think, stumbling blocks of getting people started of just playing around with Singularity, because like the big selling point is I want to build my own containers, not just use the ones that we build for you. But this is, I think a good set of exercises you can easily walk through yourself with the Scilab's documentation here on the Scilab's cloud library. And again, the links are available for the definition files here. The last thing I will point out is, I didn't get to, is in the repository of the session today, I did put some example job scripts. You can kind of see how to run your containers with a piece of code, or in this case, using one of the containers that are available on Expanse already. So the TensorFlow container. So for anybody who was in the deep learning sessions today, might find it interesting. There's just a bit of Python code doing a convolutional neural net on the CFAR data that you can run. You can run it both on compute and GPUs, and it's all through a container. So 3 minutes over time. So I'm going to stop there and take any questions, and yeah, just end the day.